All right, this is the sample test for the Unit 7 test on rational functions. This is for just the pre-governors Algebra 2, so we have things without a calculator on this as well. But right now we're in the graphing calculator section. So for these, we're supposed to graph the functions. We're supposed to sketch all asymptotes and holes and plot at least 3 points on each branch. We state the equations of the asymptotes and the x values of the holes, or state none. So I'm supposed to graph this. The first thing I usually like to do when I graph, or with any of these rationals, if I'm simplifying, is to factor them. So for this, I'm looking for what two things multiply to -10 and add to -3. That would be x minus 5 and x plus 2 if I factor this. The reason I like to do that is because I want to see, is there any factor I can reduce from the top and the bottom? If I can reduce a factor from the top and the bottom, that will create a hole. The hole is at the 0 of the reduced factor. So if I have x minus 5 equals 0, I get x equals 5. So the x value of any holes I have is going to be x equals 5. I have a tendency to forget to write my holes down when I'm graphing, so I'm just going to make a little mark here that somewhere at x equals 5, there has to be a hole. I can't put it up there yet because I don't know the y value. All right, I also need to look for the equations of any vertical or horizontal asymptotes. Asymptotes and holes occur when the bottom is equal to 0. So my other factor would be when x plus 2 equals 0. If I solve that, I get x equals -2. That's going to create a great big problem in the graph, and x equals -2 is going to be a vertical asymptote. So I can draw that on there. Make sure when you're writing your asymptotes that you're putting the equation, the x equals, or the y equals. If we have a horizontal asymptote, it's going to be y equals. For that, I'm going to look at my original function or my reduced version, it doesn't matter, and I'm going to look at what's going on with my x's. I have more x's on the bottom, so as x gets large, the bottom is going to grow much faster than the top, which means this fraction will get closer and closer to 0. So y equals 0 is the equation of the horizontal asymptote. I like to do all this without my calculator, and now I'm going to go to the calculator and put it in to my y equals. Let me turn off plot 1 that someone has on up there. I like to enter it as a fraction, so I go math to the right for number and up, and there's my n over d. I'm going to type in the original problem exactly as it was written, x minus 5 on top. On the bottom, x squared minus 3x minus 10. You could also type in the reduced version, but that wouldn't show the whole. So now I graph. Whoops, my view window's all messed up. Let me go to a Zoom 6, a Zoom standard. And that's like a typical piece of graph paper. And I can see this graph seems to look like mine does, with a vertical asymptote here at x equals -2 and a horizontal asymptote here at 0. I like to trace. You could also go to the table. If I trace, I can see an x is 0, y is a 1/2. So that's a nice point. I'm going to put that on there. That's my y-intercept. When x is 0, y is a 1/2. I might go over to -1. Now, if I trace with the cursor, it's just going to give me these decimals, and I don't really like that. But I can type in any value I want. So I type in -1, and it gives me 1. So that's a nice point. How about 2 or 1? Sorry, I'll type in 1. When x is 1, y is a 1/3. It sometimes helps me just to make sure I'm on the correct side of the asymptote. I might type in x equals 10 and make sure I'm still on top. And you can see y is 1/12, so I am still on top of my asymptote, so that's good. Let's go over here to the left side of my asymptote. So I'm going to type in x equals -3, and I can see when x equals -3, y is -1. And I could plot that point on there. I could type in -4, and I get -1/2. So I could keep going with this. Again, I'll just show you the other way I could have done this is I could go second table, and I could look for the values in my table. I can scroll up and down. You notice I do have an error when x equals -2. And if I go down in my table, I should also have an error when x equals 5 because that was the whole. So when I'm graphing and actually connecting these dots, when x equals 5, I'm going to make a little open circle there. And then I'm going to continue on to the right. And over here on the left. So I just want to be sure that I have clearly looked at my table or my trace to get at least 3 points on each of these branches. All right, let's go to the next one. So here I'm graphing -1 over x minus 4. So this is just a translation of 4 to the right. So that's nothing's gonna reduce, by the way, so there's no hole. Let me write that down, none. On the bottom, x minus 4 equals 0 gives me x equals 4. That's my translation of 4 to the right and my vertical asymptote at x equals 4. I haven't moved up or down or anything like that. So for this one, the bottom is still has more x's than the top. So horizontally, this is still going to approach y equals 0. But I do have this negative on top, which is going to flip this thing over. Again, I'm welcome to use my table to get these points or my graph. I'm just going to go clear this one out. So on the top, I had -1. And on the bottom, I just had x minus 4. All right. And if I graph that one, I can see it looks like I thought it was going to, where it moved 4 to the right, it had the asymptote at 0. And then what the negative did was flip this over. So instead of having a branch in the upper right and the lower left, like my first graph did, this has been flipped vertically because this negative was sort of on the outside or on the entire fraction. So normally my shape from this, I go 1, 1, and then a half, a third. Again, I could trace or use my table to get those points as well. And then since there was no holes, I can just connect these. And if I look at the table just for confirmation, you can see there are the values I had that I was plotting on my graph. All right, let's go down to number 3 here. Number 3, it says the graph of the parent function is shown. Circle each function which belongs to this same family. So what I'm looking for here is I'm looking for a graph that has a vertical asymptote, that has a slanted asymptote, and it has 2 branches here that make sort of an upside down U shape and a right side up U shape. So I'm not sure what the equation looks like for that, but I could go ahead and I could put each of these into my calculator and I can see what they look like. And the same family of functions is going to be the same overall shape of the graph. It could be moved, it could be stretched, it could be shrunk, it could be flipped, but it has to have the same overall shape of that parent function. So this looks like a line, so that's bad. That's a line, so that is not part of the same family. Let me go back to my next function. Next function, I've got x squared plus 3x plus 1 on top, and on the bottom, I've got x plus 1. Notice I am making sure I put everything in with that fraction notation. Now this one has a slanted asymptote right here, but it doesn't have the U shape up here and the U shape down there. Its range would be all real numbers for this one, so this one's not good either, right? This one looks something like this. So that's not good. All right, let's go to my next one. Clear out what's up there. I've got x minus 1, the quantity squared, all over x. Oops, graph. Now this one looks like it's making the same shape. My asymptote is not in the same place. My vertical asymptote is still at 0, and I can't really tell if my slant asymptote has moved up or down or it's been stretched or anything, but that doesn't matter because this has made the same shape. So this is a good response because it had the 2 UE shapes and the slant asymptote with one vertical asymptote. I can already tell that this last one is not going to work because the bottom is bigger, so this is going to have a horizontal asymptote at y equals 0, so that doesn't work. You may not have noticed that, and if you didn't notice it, that's okay. We would just come up here and we would put it into our calculator. X plus 1. On the bottom, I've got x squared plus 3x plus 1. And when I graph that, like I said, it's going to have a horizontal asymptote at 0, but it also has these 3 branches. Crazy. It looks nothing like the thing in the picture. So my only answer here was that one. Okay, turning the page. We've got number 4 here. Which of the following is a possible graph of a rational function where the domain is x is not equal to -2 or 3? That means that I could have a hole or a vertical asymptote at x equals -2 or 3. Those are the things that happened in these graphs. And then also I've got y is not equal to -1 or 0. So those were usually from the horizontal asymptotes or the holes, or sometimes we had range restrictions from maximums and minimums, but those would usually be greater than and less than. So let's start out with our x's. X can't be equal to -2 or 3. X is not equal to -2, x is not equal to 3. So that's good. X is not equal to 2, x is not equal to 3. So that's good. Now this one, we've got x is not equal to 3, but not x is not equal to -2. So let's skip that one. Here I've got x can't be -2 or 3. So that's good. X can't be -2 or 3. So that's good. So I've eliminated one of them based on the domain. How about the range? Y can't be equal to -1 or 0. Looking at this one, y can't be 0 because that's the horizontal asymptote. Y can't be -1 would be the value of this hole. And as I look up and down, there's no other place that covers y equals -1. There's no other place that covers y equals 0. And there's no other values missing. So this one looks good. In my next one, it looks like y could be greater than 0 or y could be less than or equal to this point. But this gap here between -1 and 0, there's nothing in there. So that's not okay. On this next one, we've got our range would be all reals because this branch goes up and down forever. So that's not it. On the next one, we'd have y can't be equal 0 right here, but over here y does equal 0. So again, this branch covers every single y value. So this one would have a range of all reals as well, and that's not going to be our answer. All right, number 5. The following is a graph of 1 over x squared. And it says, which of the graphs shows this transformation? So what do we have to do? We have to move on the bottom. A -3 on the inside is going to move us 3 right. And we also have this negative up here on top, which is going to flip us vertically. So if I flip vertically, I should be going this way instead. And instead of having my asymptote right here at 0, my asymptote should be over here, moved 3 to the right. All right, so this one was moved 3 to the right, but not flipped. This one they didn't do anything to. Let me scooch down, get some more in here. This one looks like it's moved 3 to the right, and it was flipped upside down. So that's good. Let's double check that none of these match as well. This one was moved down, so that's bad. This one was moved down and it was never flipped, so that's bad. It looks like this is our only answer. If you wanted to, you could also type this into your calculator and confirm that this was the graph that you wanted.